Hi, I'm David Peruskevich. I'm one of the customer assurance people here at the Behler-Young company. Today we're going to talk about setting up the blower on an Axion rooftop unit or a 582K. Now the 582K, or Axion as it's called, has a vane axle ECM blower motor. It's a little different than what we're used to. Some of the issues that have come up with this is a lot of it's been tied to not properly setting up your static. Belt drive units, it wasn't, I guess, such a big issue. We may not have set those up properly either, but in this case, we have to make sure we get this set up properly. It's pretty straightforward. The first thing we need to do is find out what our CFM requirement is. This is a 3-ton unit, 400 CFM per ton, 1200 CFM. That's the CFM we need. The next thing I need to do is I need to check what my static pressure is. Now, I have a digital manometer here. It's a tube probe. We can use the old style, whichever. I think pretty much everybody's got a digital nowadays. They're fairly inexpensive, but it's something we definitely should have. It's good for gas pressure, pressure switches on 90% furnaces, and also checking static. So this is a dual probe. So I'm going to put my positive in my supply duct, my negative in my return duct. Okay, you have your tubes, which are supposed to face into the airflow. Now, when I say duct, I don't mean into the doors of the unit. I mean actually in the drop below the unit. The pressure in here is going to be way different than you actually have. So we want to make sure we check our static pressure in our return air drop and our supply drop. So we're going to get two readings, one positive, one negative. So for instance, in my supply I might have 0.4 inches, and in my return I might have 0.5 inches negative. I'm going to add those two together, 0.4 plus the 0.5, I'm going to have 0.9 inches of static. So with that information, I'm going to know how to set this thing up. So the next thing I'm going to do is I'm going to go to the chart that's right on the unit here, and I've determined I need 1200 CFM for my 3-ton unit. I'm going to go down here, find my 1200 CFM. I'm going to follow it across till it matches up with my static, which I have 0.8 or 1.0. So if I follow across 1200 to 0.8, 7.3, 1.0 is 7.9, so we're going to go in the middle, let's say 7.6. That's volts DC. So then I'm going to take my voltmeter, I'm going to put it on DC volts. Now the way this amp works is this thing gets power all the time. There's DC voltage, 10 volts DC coming out of the motor going to the control board. There's a potentiometer on the control board that's going to dictate the speed. So I'm going to take my DC voltmeter, and on the board here I have both DC terminals, negative and positive. On the board there's DC voltage terminals, negative on the bottom, positive on the top. I'm going to set my DC voltmeter. I've got it on 20 volts because I'm looking for 10 volts DC, which is coming from the motor, going through this potentiometer. We're going to change it to something else. So when we looked at our chart, the chart told us we needed to set it to 7.6 volts DC. So this is pretty straightforward. I'm going to put the black probe on the negative. I'm going to put the red probe on the positive. 7.2 volts, so it's too low. So what I need to do is I need to turn my potentiometer here. So 7.59, 7.6. So now I'm set at 7.6 volts DC. So what will happen is on a call for lower, it's going to send the 7.6 volts DC to the motor. It's going to bring the motor up to the appropriate speed, deliver 1200 CFM at the 0.9 inches of static that we have, which is the proper way to set these up. If you just come up and crank this thing up all the way, we're going to overwork the motor. It's going to start going off of this internal overload, or we're going to burn it out. If we don't adjust it and we have too high a static, we won't deliver the proper airflow. Some of the quick checks that we should do after doing this is still check our temperature rise. If I look at my nameplate tag, it'll tell me what my temperature rise is. I stick a thermometer in my return air duct, stick a thermometer in my supply duct, keep the thing on in heating, and that temperature rise should fall in between the rating on the tank. If it doesn't, it's indicating that I got an airflow problem. So if this is set up right, my temperature rise is still up too high, I might have an airflow problem, I might have too high gas pressure. So once this is set, I disconnect this, and I'm ready to go. And as you see, the unit does not have to be running to do this setup. The blower's off, but I do have power on the unit. I'm Dave Behler-Young with the Behler-Young Company. And that is my tip today on setting up the blower on a 582K or Axion rooftop unit.